The examples handout that was distributed to you, we're going to look at some of the odd problems on this one, and then you're going to practice the even ones in class before you go home and try these at home. There is one extra thing from the previous video that wasn't covered, and that's the idea of a coterminal angle. So to touch on that very quickly before we get started with the examples, a coterminal angle is going to, coterminal angles share a terminal side. So if I'm in standard position in the coordinate plane, and I have this angle theta, the coterminal angle to angle theta is going to be the angle in the opposite direction that completes the rotation. So if my theta is positive, then I am going to subtract 360 from my angle, and that will give me my coterminal angle. If my angle is negative, then I'm going to add 360, and that will give me my coterminal angle. So when you think about coterminal angles, you're essentially completing the 360-degree revolution. So if I have a positive angle, the coterminal angle shares the terminal side of my angle, but it completes the rotation in the opposite direction. So if theta, for example, was 120 degrees, then my coterminal angle is going to be 120 minus 360, which is going to be negative 240 degrees. Okay, so let's take a look at the example worksheet in the class notes, and like I said, we'll look at the some of the odd problems, and you can do the even problems. So number 1 through 6, you are converting degrees to radian measures. So in number 1, we have 36 degrees. To convert from degrees to radians, then we multiply by pi over 180. Now this says to give exact answers and don't round. So this is 36 pi over 180, and I'm going to need to simplify that fraction down, but I'm going to leave it in terms of pi. So when I put this in the calculator, or however you go about reducing the fraction, you're not going to put the pi in there. You're strictly going to reduce the 36 over 180, and that's going to give you the fractional component, and then you add the pi back in. So when I reduce 36 pi over 180, what I'm really reducing is 36 over 180 times pi, and 36 over 180 is going to reduce to 1/5. So this will be 1/5 times pi, which is pi over 5 for my radian measure. So this would be pi over 5 radians. The same thing for number 3. If I look at number 3, I have negative 145 degrees, and I'm going to convert that to radians, so I multiply it by pi over 180, and this gives me negative 145 pi over 180. And so however you go about reducing your fraction, again, whether you use the calculator or you use just the simple reduction method that you learned in elementary school, this is going to give you negative 29 pi over 36 as our radian measure. And in number 5, if we convert 18 degrees, so we have 18 degrees that we're going to multiply by pi over 180. This gives me 18 pi over 180, which is going to give me pi over 10. Now for 5 through 12, it's a similar setup except we're converting from radians to degrees. So in number 7, I have 13 pi over 30, and to convert from radians to degrees, then I'm going to multiply this by 180 over pi. And the way you keep it straight is whenever I convert from radians to degrees, I'm always going to have this little pi in my radian, and I want to make the pi go away. Well, to make the pi go away, the pi has to be on the bottom. So from here, you can either multiply across or you can simplify before you multiply across. So I know that my pi's are going to cancel out. And my 30 over 180, I can reduce to 1 over 6. And then I'm just left with 13 times 6 as my degree measure, so this will be 78 degrees. In number 9, if I have negative 2 pi over 5, again, I'm going to multiply that by 180 over pi. And from here, I can reduce it down or just multiply across and reduce at the end. It doesn't make any difference. So I know that my pi's will cancel, and I know that my 5 will reduce my 180 into 36. So then I have 2 times 36, but it's negative. So this will be negative 72 degrees. And then in number 11, we have negative 7 pi over 9. We multiply this by 180 over pi. My pi's are going to cancel. My 9 reduces my 180 to 20. And so I have negative 7 times 20, which is going to give me negative 140 degrees. Now in numbers 13 through 18, this is where you're determining the quadrant in which the terminal side of the angle will fall. So in number 13, sometimes it's very helpful to draw a picture to represent your situation. So if I am drawing negative 156 and it's in standard position, my vertex is at the origin and my initial side is on the x-axis, and negative 156 means it has to move in the clockwise direction. So I'm going to be somewhere here when I move in the negative 156 degrees direction, which means I'm going to fall in quadrant 3. For number 15, if I have negative 5 pi over 3, and you can work with your radians if you want to. It's always more helpful for me if I convert it over to degrees just because my brain thinks in degrees. So I'll have negative 5 pi over 3 times 180 over pi, and I'll simplify this down a little bit. So this is going to be negative 300 degrees for me. And so I'm going to draw in my coordinate plane. And if I'm negative, that means I'm moving in the clockwise direction. So this will be negative 90, negative 180, negative 270, and negative 300 will be here. So that means I'm going to fall in quadrant 1. If you skip over to number 19 through 24, this is where you're finding the coterminal angles, and you want a positive and a negative coterminal angle with the given angle. So in number 19, what we look at when we work with problems like this is I start with an angle of 70 degrees. And so since I'm positive, I am going to subtract the 360. So 70 minus 360, and this is going to give me negative 290 degrees will be my coterminal. Now I can also have a coterminal angle that is more than 1 revolution, and this is where you would add 360 degrees to it. And so this will give you a positive 430 degrees. That would also have the exact same coterminal angle as the 70 degree angle. And for number 21, as another example, we have negative 210 degrees. Well, since we start with a negative, we're going to add 360 to it. And so this is going to give me a positive 150 degrees. And to find the other angle, I can subtract 360 from it, and that's going to give me a negative 570.